Hi and welcome back to another lesson in the physics video series. Today we're going to conclude our studies on projectile motion by summarizing everything we've learned as well as highlighting some important facts about projectiles. Okay, let's get started. First thing we're going to do is recall that there are two basic parabolic motions that are covered in the Regents curriculum, the full parabola and the half parabola. The full parabola begins by launching something at an angle to the horizontal, and it makes a full parabola with a rising zone against gravity and a falling zone with gravity. Whereas the horizontal projectile is only the falling zone, and this is a horizontal projection, so there's a 0-degree initial angle. There still are just 5 steps for both of the types of projectiles. The first step deals directly with components. For the parabolic projectile, you have the vox and the voy, VO cosine theta, VO sine theta. But in the horizontal projectile, the vox is the V0 and the VOY is 0. There is no vertical initial speed till after it falls. Then you find the time of flight, as you see here, the two different versions of the time of flight, and of course the equations that develop these. This is from Formula 3, solve for t and double it, and this of course comes from Formula 4. Next we would find the range. The range is equal to velocity times time, so the horizontal velocity is what carries the projectile sideways, vox t, meaning that you would use the information from steps 1 and 2 to fill into formula here. There is a little secret weapon which we developed where we remove the time parameter and we have the double angle formula in its replacement. You can go back and watch that video to see how that was derived. And the maximum height, which comes from Formula 5 for the full parabola, and it has its counterpart from Formula 4 for the half parabola. Last but not least, we have the impact velocity, VF, in red, and its angle below the horizontal. The red impact speed is the Pythagorean of the vox, which never changed, and the free fall impact speed, VFY, in blue, which is calculated either if you knew the height from which it fell or the time it took to reach the ground. Either way, the VFY is calculated and put into the Pythagorean theorem. Then you take the arctan of the y value divided by the x value, and you get a negative angle, which means it's below the horizontal. And finally, let's talk about some important facts about projectiles. The first important fact is that the maximum range for a full parabolic flight will happen when the angle is 45 degrees. That's when the vox equals the voy. And if you went down to this formula here, VO squared with G sine 2 theta, 2 times 45 is 90. The sine of 90 is 1, and you get the maximum range. Of course, the maximum height is when the angle is 90. So if you just shot this straight up in the air, it's like the problems we did a few videos back where we threw something straight into the air. That's actually a vertical projectile. Fact number 3, complementary angles have the same range. 30 degrees and 60 degrees and 20 and 70 degrees all have the same range. The higher the angle, the higher the distance to the turning point along the axis of symmetry, but they still land in the same spot. That was proved in the last video when we did a 30 and 60 degree angle comparison. Fact number 4, vox and voy reciprocally change based on the angle. As theta increases, the vox decreases and the voy increases, and the converse is also true. This is a property of sine and cosine, which you should remember. As one increases, one decreases. Fact number 5, the vox remains constant for the entire flight. This is an important fact because there is no sideways gravity, there is no sideways or horizontal acceleration. So the vox is a constant speed. Number 6, vertical speed component at y max equals 0. When the object reaches its high point, it stops rising because it has no more vertical speed. It has decelerated to a vertical speed of 0. Fact number 7, vertical acceleration is gravity, which is 9.8 meters per second squared. The only acceleration in both of these problems is gravity. Gravity points down, and it accelerates objects at a rate of 9.8 meters per second squared. If you are dealing with parabolic projectiles and you have a rising zone, you are fighting against gravity, so you are decelerating. And then once you cross the axis of symmetry past the turning point, then you are in the free fall zone. Horizontal projectiles are only in the free fall zone. The time of flight depends on the height. This is an important fact exclusively for horizontal projectiles. The time of flight depends exclusively on the height. Time is equal to root 2y over g. There's no other variable here that matters. The higher it is, the longer it takes to hit the ground. And finally, friction will reduce the y max and shorten the range. So in problems of this nature, they could ask you about friction, and the level of our course will just include information that an object won't go as high and it won't land as far away. Of course, there are tremendous amounts of mathematical development that can show you precisely the new path, but we don't deal with it at this level. And there you have it, the whole summary sheet in one view. You have the important facts. Now there are more than 9 facts that go with this concept, but these are the ones that stand out as being concept questions that pop up very often on the Regents, and these are the 5 steps that are the same for both types of flight. I hope you enjoyed this lesson. I thank you for watching, and I'll see you in the next video.